In this video tutorial, I'm going to try to distinguish between limiting reactant and excess reactant. If you have two reactants, for example, hydrogen and oxygen, and you are given amounts of those two reactants, you have to decide which one is limiting reactant and limits your production. For sake of a problem, let's assume we have 4 moles of hydrogen versus 1.5 moles of oxygen. And the question is, which one is limiting reactant? There is two steps in this process. Divide the moles of the given reactant by the coefficient. Hydrogen is 2 and oxygen has coefficient of 1 in balanced equation. And step 2 is pick and choose the smallest of the two ratio, and that's your limiting reactant. So I'm going to divide 4 moles of hydrogen by coefficient of 2. So 4 divided by 2, and I'm going to compare it with oxygen, which is 1.5 mole given in the problem, divided by the balance coefficient of 1. 4 divided by 2 is 2. 1.5 divided by 1 is 1.5. 2 is bigger than 1.5, so the smallest is indicating that that reactant is limiting reactant. So I'm going to say oxygen is the limiting reactant. I'm also going to do another extension of this problem. I'm going to see how much water they each are producing in order to get across that the limiting reactant really limits the amount of production. So what I'm going to do is start with 4 moles of hydrogen. Then I multiply it by proportionality. For every 2 moles of hydrogen, I produce 2 moles of H2O. So it's okay if you write it as a ratio like that. 2 moles of hydrogen. And I put moles of hydrogen in denominator because if you have like terms in numerator and denominator, they cancel each other out. Every 2 moles of hydrogen from the balance equation produces 2 moles of water, H2O. Now if you multiply the number, 4 times 2 is 8, divide by 2, you get 4, so you produce 4 moles of H2O. Let's do the same treatment for oxygen. I have 1.5 moles of oxygen. I will go to my balanced equation and look at proportionality. I see coefficient of 1 for oxygen versus 2 for H2O. I put oxygen below in the denominator, 1 mole of oxygen, cross them out, 2 moles of H2O in numerator. The final answer will have the units on the numerator of the last ratio. 1.5 times 2 divided by 1 is 3, and you produce 3 moles of H2O. Definitely 3 moles of H2O is smaller quantity than 4 moles. So this is smaller, and this indicates that oxygen, O2, is limiting reactant. Now these two calculations was not needed. Although I have an intention in mind, I want you to learn eventually how you are going to play with numbers. And I want you to realize that limiting reactant limits your production. If you would have used 4 moles of hydrogen, which is excess, you would produce 4 moles of H2O, which would have been the wrong answer. If you use the limiting reactant, 1.5 moles of oxygen, you produce the accurate amount or the lesser amount. By the way, this eventually will be known as theoretical yield, what you can produce based on calculations. Now let's do another problem. This time, instead of moles, I'm going to give you grams, and we are going to see what happens. So problem number 2, I have magnesium plus oxygen giving me magnesium oxide. I have 2 moles of magnesium for every 1 mole of oxygen, giving me 2 moles of magnesium oxide. A balanced equations is extremely important. Now what I want you to remember is, remember that triangle of mass, moles, molar mass. In this fashion, if you want to find moles, it's simply mass divided by molar mass. If you are interested to find mass in grams, it's simply multiplying N which is moles times M capital for molar mass. So M for mass is N times molar mass. Make sure you know these two equations very well, so you can go back and forth between quantities and convert them appropriately. So let's say we have 12 grams of magnesium and we have 48 grams of oxygen. And the question is, what is your limiting reactant? First step is you have to convert grams into moles. Otherwise, you cannot use balanced equation and the coefficients. So first step, I'm going to convert moles. So I'm going to divide mass by their molar mass. In this case, it's 12 grams of magnesium divided by its atomic mass, which is approximately 24 grams. For oxygen, I have 48 grams. And I'm going to divide it by oxygen's molar mass. Now remember, this is diatomic. You have 2 oxygen for every molecule. So the molar mass is 2 times 16 rather, grams per mole. When you do this, the first quantity for magnesium, you produce 0.5 moles of magnesium. For the second quantity, you're going to produce 1.5 moles of oxygen. Now, then again, in order to find which one is limiting reactant, we are going to divide by the respective coefficients and pick and choose the smallest one. 0.5 divided by 2 versus 1.5 moles of oxygen divided by 1. 0.5 divided by 2 is 0.250. 1.5 divided by 1 is 1.5. 0.250 definitely is smaller than 1.5. So this indicates that magnesium is limiting reactant. Now I also want to do another treatment. I want to see if it's really limiting reactant. If that's the case, how much magnesium oxide I produce using limiting reactant information versus excess, which is oxygen in this case. So I'm going to go after magnesium first. I have 0.5 moles of magnesium, so I start with that. 0.5 moles of magnesium. Now let's just look at the proportionality. Every 2 moles of magnesium gives you 2 moles of MgO. So in denominator, I put 2 moles of Mg. So moles of Mg cancel, not the numbers. In the numerator, I put 2 moles of desired product, in this case MgO. Final answer is 0.5 times 2 divided by 2, which is 0.5. I produce 0.5 moles of MgO produced. Now let's compare it to the excess for oxygen. We have 1.5 moles of O2. Let's look at proportionality. You see the coefficient of oxygen is 1, and then coefficient of MgO is 2. So I put 1 mole of oxygen in denominator and 2 moles of MgO in the numerator. Moles of oxygen goes away. 1.5 times 2 divided by 1 is 3 moles of MgO. So if you use the excess, you produce exaggerated amount. It's incorrect. But if you use your limiting reactant, you will see you have produced lesser quantity of magnesium oxide, which is actual based on limiting reactant. So this is reinforcement that the limiting reactant was oxygen. Then again, remember, these 2 quantities or calculations are really not needed, but I want you to have it with an intention in mind, because gradually you have to become expert problem solvers. Now let's go after the last tutorial of this session, which I want to mix units. I want to give you some moles and some mass in grams, and just tell you respect the units so you don't get confused. Let's say we have 13.5 grams of aluminum. Then I have balanced the equation for you versus 0.75 moles of oxygen. The question is, which one is limiting reactant? Since oxygen is already in mole, I leave it alone. I go after aluminum. I'm going to find its moles. Moles is mass divided by molar mass. In this case, 13.5 grams. Atomic mass or molar mass of aluminum is give and take 27 grams per mole. When you do this, you will get 0.5 moles of aluminum. For oxygen, I just bring it down so I know what I have, so I don't get confused. 0.75 moles of oxygen. In order to decide which one is limiting reactant, since now we have them both in moles, let's divide by their respective coefficient. 0.5 aluminum divided by 4 versus 0.75 divided by 3. Let's see what we get. 0.5 divided by 4 is 0.125. 0.75 divided by 3 is 0.25. Definitely 0.125 is smaller than 0.25. Therefore, this is indication that aluminum is limiting reactant. Now, then again, I want to do the same treatment as before. I want to see how much aluminum oxide I produce if I use limiting reactant, which is correct, versus excess reactant, which would have been incorrect. So let me start with moles that I have. I know I have 0.5 moles of aluminum. So I start with that, 0.5 moles of aluminum. Let's look at the proportionality. For every 4 moles of aluminum, you produce 2 moles of aluminum oxide. So 4 moles of aluminum intentionally in denominator so they cancel each other out. In the numerator, I have 2 moles of product, Al2O3. This is 0.5 times 0.5. When you multiply, you get 0.25 moles of aluminum oxide. Now let's do the same treatment with oxygen. You have 0.75 moles of oxygen. Let's look at our balanced equation, and proportionality is 3 to 2. So 3 moles of oxygen versus 2 moles of product aluminum oxide. Moles of oxygen cancel each other out. You have 0.75 times 2 divided by 3, which is 0.5 moles of aluminum oxide. Aluminum produces the lesser quantity of aluminum oxide, therefore this is reinforcement as indicative that aluminum is the limiting reactant. So Al is limiting reactant. Until next tutorial, although the last two calculations are not needed, but pay attention to them, see if you appreciate the proportionality and how it's being set up, because I'm going to use it quite often and I want you to be able to use it also easily.